This Metroidvania is a game I've been working on for over 2 weeks now. It's my largest project yet, and I hope it shows. I've already implemented controls, collisions, and even some graphics. I should mention though, that the game is very early in development, and I want to showcase it in multiple parts at various stages of development. My main motivation for making this game is actually to practice working on larger projects, but I specifically chose a Metroidvania game because I thought it would be more fun to work on. You play as this black blob, and you can run and jump around the environment shooting fireballs. I've designed some rooms and added a basic collection of sprites and tiles. The camera will also follow you wherever you go. I've also added some enemies, which aren't very dangerous, but could definitely kill you. As time goes on, I'd like to implement more features, such as items, boss battles, and maybe a map system. Before I wrote any code, I first wrote a plan for what features I wanted to implement, and in which order. In previous projects, I've sometimes felt overwhelmed with what I needed to do, which made it more difficult to work efficiently. Maybe I wanted to adjust the controls and enemy patterns and room layout, but managing all of these things at once turned out to be quite stressful. I knew if I didn't address the problems this time, it would kill me. The order isn't so rigid, but in general I should be moving downward. You can see the final step is to create the next plan. I thought it would be unwise to plan out a whole game without having a specific vision, so I decided to only determine the later steps once I have a stronger foundation. For the rest of the series, I'm only going to cover in detail the steps that I think are interesting and feature useful concepts. So even though the player movement is essential, there's not much to it beyond certain buttons determining a specific velocity. With that said, let's move on to collisions. Here's the situation. I've set up the player to have a horizontal velocity and a vertical velocity, which are both influenced by user input. Every frame the game runs, the player moves to where the velocities are pointing. I've also set up these tiles which should push the player back when collided with. There's many methods for achieving this behavior, each with their own strengths and weaknesses. To be honest, when starting a new project, I dread writing collision detection, because it's not particularly fun. It needs to be finished before moving on to features that are fun, and depending on how comprehensive it is, it can take a really long time to write and potentially longer to debug. I think my main problem was that I would write collision systems that were more complicated than necessary, so I made this collision system relatively simple. This also has the added benefit of making it easier to reuse code in future projects. I'll now explain what the system does for every frame. To start, both velocities are divided by the value of the velocity with the greater magnitude. Let's call these the step values. This results in one magnitude that's equal to 1, and another that's less than 1. The player is then moved by the horizontal step, and then the vertical step. This process repeats, and if any action results in a collision, the action is reversed. This process continues until the steps account for the player's velocity, at which point the player's position is updated. By checking every pixel, it's impossible to go through walls at high speeds or cut corners. And also, since the horizontal and vertical steps are separate, whenever a collision occurs, it can be determined whether it took place at a wall, floor, or ceiling, which can be used to change each direction's velocity separately. I think the system functions well, though I do wonder if there's a more efficient way to achieve the same result. Collisions are checked many times every frame, so how collisions are checked can have a significant impact on how well a game runs. As usual, I don't claim to know the right answer, but I believe this solution is sufficient. Once I set up a few more features in the game, I then decided to work on a health meter. You can see it all the time in the top left corner, and honestly I think it turned out quite well. You can see each block represents one hit point, and including the blank spaces, you can see how much health you have in total. If you take damage, or are at full health, there are also some neat coloring effects that appear. All of this behavior is determined by only a few variables, and the code itself is quite compact. Basically, for each health point available, this specific sprite is drawn at a particular coordinate, but each successive block is offset horizontally by the width of the previous blocks. If the block's number is greater than the current HP, it's tinted black. There's various ways you can change the color of a sprite, but how you do it really depends on what resources you're using to make the game. This tinting method is also used for the other color effects. As for the wavy effect, this is achieved using the sine function. It essentially returns the height of a sine wave at a specific point, which is really useful for wavy and circular effects. The output of this function is used to affect the vertical offset of the blocks. The reason that the blocks don't move in unison is because each block has a slightly different input value. The waves also die down when you're weaker. There's one last thing I want to talk about. You can see that when I take damage from this enemy, I lose 2 hit points, but when I take damage at 2 hit points, I only lose 1. This is because of a specific feature I implemented, that you can only die if you take damage at 1 HP, and if you get hit by an attack that would normally kill you above 1, your health simply drops to 1. The purpose of this is to make any death more predictable, since you know that as long as you have more than 1 HP, you can always take at least 1 extra hit. Having finished my first set of goals, my next step is to work on the second plan. It's not been decided yet, so please let me know what you think of the project so far and what you would like to see implemented in the future, because I might take it into consideration. Also, consider subscribing to my content so that you can keep up with future updates. That's all for now. Bye.